Hi everyone, welcome back to my channel Tech with Yashwant. In this video, I'm going to show you how to run your ROS application on an EC2 instance which has got Ubuntu 20.04 installed. So in order to run this, there are a few prerequisites. Let us understand what are those prerequisites. Firstly, you should have an AWS account with the permission to create an EC2 instance. Secondly, you should go ahead and install some of the dependencies in order to run ROS application, including ROS application. Thirdly, you should have a sample application which you can run on the cloud server. Fourth, we should also have a ROS bridge library installed on our local machine. So the idea is very simple. So we have your local machine here and the cloud server here. So the idea is to bridge the communication between these two so that they can operate and collect and process the data. So imagine you can just publish your message here, and on the cloud server, all the processing happens and you can get the result on your local machine. So we are in an era where you cannot process the message on your local machine, at least to some extent. So rather than running it on your local machine, you can just offload that to a cloud server which has got more capability. So if you're interested to build this, let's get into the AWS console and start building this project. All right, so if you see here, all the steps and the code that are required for this demonstration is in this GitHub repository. So I'll make sure to provide the link to this in the description box below. Feel free to check that out. Now let's go into the AWS console here. So let us go ahead and create an EC2 instance. So I'll click on EC2, click on launch instance. I'll just provide a name, ROS server. And under AMI, like I mentioned, we should select 20.04 Ubuntu. So let me click on browse AMIs, go into AWS Marketplace, search for Ubuntu 20.04. You'll see this Ubuntu 24.04 by Pro Computers. Select that one. And you'll have to subscribe if you're doing it for the first time. Then that server will be automatically added for you. So it's not a server, it's an AMI. And go ahead and select the free tier eligible instance type. So I'm just going to go with t3.small. And let's go ahead and create a new key pair. So I'm just going to name it ROS server. Click on create key pair. And networking, I'm going to leave that as default. Let it be in default VPC. Make sure that auto assign public IP is enabled. Now let me select an existing security group, which is default. And I'll change the storage to 10 GB. If you're comfortable with 8 GB, go ahead and select 8 GB. Now let me go ahead and launch the server. It's going to take at least a minute for all the things to be up and running. So now let me click on the instance ID. So the server itself is ready, but let's go ahead and see the code as well. Firstly, we need to install all this user data script. Basically, it is going to install some of the softwares and the dependencies in order to run a ROS application, including software properties common, curl, vim, LSB release, and also if you see, we are installing ROS as well, and ROS bridge server. All these things are required. So we need to run this on the server in order to be installed. Copy the URL and just run git clone, and all the things that are in this repository will be inside the server. So before that, I will also explain what is the Python script that we are going to run on the local machine, which will connect to the cloud server. So let me get into bridge.py. So if you see here, I'm importing time and roslibpy. You need to run pip install roslibpy. I'm going to explain that again. So once you have that, you need to change the host here. Basically, it is going to create or connect to your ROS server, which is your cloud server. You need to get the public IP address of your instance and place that here. And make sure in the security group, port number 9090 is open. And here it is trying to connect to the ROS master via ROS bridge. And if that fails, it is going to print fail to connect. Else it is going to print the client is connected on the server itself, and it will start publishing a number one by one, and you can see that here the count is increasing as and when the connectivity is established. Okay, so remember, this code needs to run on your laptop or your local machine, and on the cloud server you will just see it is connected. But this is a simple application, but think of running a ML algorithm on the cloud server, and you just send the message from your local machine to the server. So that's how you can scale this application, but I'm just explaining a sample application for you to understand. Okay, so now let me go back here. I think the instance is up and running now. Let me click on connect. So if you want to go with SSH client method, you can do that as well, but I'm just going to use instance connect method for now. Let me go ahead and click on connect. So it will open up a terminal on my screen or the browser. All right, so let me zoom in a bit so that you can also see that clearly. Okay, now let me clear the screen and become a super user or a root user. Okay, so as you can see, I'm a root user now. So firstly, let's go ahead and clone this repository. Before that, as a practice, let's go ahead and update this system. So to update, I'll run apt update -y, and this is going to update the system, and it will be done in a minute or two. Alright, so the update has been completed. Now let us go ahead and install Git. So to install Git, you can run apt install git -y. So this is going to install Git if it is not present. If it is present, it will say that Git is already there. So it has got installed now. Now let me clone the repository. I'll just run git clone and paste the URL that I copied, and it has copied now. Let me get into the folder. Now, if you see here, I'll just run ls-lrt, and you can see all the things that were there on my GitHub repository is inside the server now. So the one that we are interested is script.sh. So if you see here, this script doesn't have the execute permission. So let's go ahead and provide the execute permission. So to do that, I'll run chmod +x and the name of the file. Now if I run ls-lrt, you can see +x or execute permission added. Now let's go ahead and run this script, which will go ahead and install all the dependencies. So I'll just say // and the name of the script. It will go ahead and run the installation script. So it is going to take a minute or two for all the installations to be done. So meanwhile, what you can do is go to this repository, scroll all the way down. You should be in this section where you see for bridge network, you should have this ROS launch bridge server installed. So that is basically present here in the last command. So make sure it is installed correctly. And after the installation is completed, you need to run the second step, which is to source that into a bash file. So if you do not run this, you won't be able to run the next commands. So once you have this installed, you can run this, and then you can go ahead and run ROS launch bridge server and WebSocket. So it is going to establish a WebSocket connectivity to your cloud server as well as your local machine. So before that, you can also clone this and keep it on your local machine, or copy this bridge.py code into your local machine. So I've already done that. So I need to edit one of the things here. Like I mentioned, I need to place the EC2 instance public IP and make sure 9090 is open on the security group. Okay, so let's verify that. Let's go into the instance and let me copy the public IP address. Okay, so I'm just gonna paste that here. Okay, don't forget to save the file, and let's see if the installation is complete now. It's still running. So let's give it a moment for it to complete. Let me also show you how to verify the security group is allowed or not. So go back to your instance. If you scroll down, you see security here. Open this security group in the new tab, and basically you need to allow 9090 port here. Let's do that. I've allowed all the traffic to this, but let me show you how to do that. So scroll down here, click on add rule. Here you need to select basically custom TCP, and you can provide the port range as 9090, and from the source, either it can be your own IP address or from your entire internet. So I'll just select 0.0.0.0/0, which is meaning the entire internet, and you can add a description and you can save the rule. Okay, so this is how you add 9090 port on your security group. Again, so make sure to add it, else it is going to fail or time out with an error saying you cannot reach the server. Okay, now let's go back and check again. Okay, so it has completed. So let me clear the screen. Like I mentioned, we need to run the second command here. So let me go ahead and copy the second command, which is sourcing to the bash script. I'm gonna run this now. So if you get this, that means that you are able to install all the things correctly. If not, there will be some issues. Okay. Now on the server, let's go ahead and run this ROS launch bridge server. Basically, we are activating the WebSocket and the bridge server. So if you copy this and execute this here, let me run it. So you should see something like this. ROS bridge WebSocket server started at WS workspace 0.0.0. and the port number, which is 9090. And if you see, it is nowhere saying the client is connected. So we have not established a single connection at the moment. So observe this carefully. I'm not gonna stop the recording now. Even if it fails, I will leave it as is so that you can learn. Now if I go back to my Visual Studio Code here, one important thing that I need to install is this one, pip install roslibpy. If you see here, I've imported that as well in my code. So you need to have that. If not, go ahead and run this. In my machine, it is already present. So I'm gonna run the Python script. So to run the Python script, it's simple. Run python 3 and bridge.py, right? So I'll say bridge.py, and I'll hit enter. Now if you see, it is connected to ROS master via ROS bridge, and it has started publishing the messages as well. Now if I go back to instance, you will see one client got connected. See, firstly we saw only this line which just mentioned that the bridge is open now. Now if you see, one of the client got connected, right? Now if you see here, it is still connected, and you can also see the messages are being published. Now let's say I will go ahead and stop this WebSocket. So if I just hit Control C, it is killing that and it has shut down the ROS client. Now if I go back here, it is automatically stopped publishing as well. Okay, so if you stop the connectivity on the server, or if you stop producing the message, automatically the entire process will stop. So this was the whole idea for me to explain how exactly the ROS bridge works. So if you are liking the content that I'm creating, please consider subscribing and share it with your friends. Thank you, and I will see you in the next video.